Good morning, friends. Today we are going to discuss about the principle of metal forming, bulk deformation and sheet deformation process. It is an introductory lecture related to metal forming process, where as the title slide tells about that, we'll be discussing about all those processes like say rolling, forging, extrusion and drawing. We are discussing about metal forming because metal forming is a very important area of manufacturing, and most of the metal manufacturing is done by metal forming. It's a very productive process, and as extensive production has to be carried out through this process, so that is the importance of learning this process in details, even in the initial parts of the manufacturing classes relevant to all disciplines all over the world. So all over the world, the engineers have to learn the manufacturing subjects, and very specifically for the metal forming process, because a lot of products are coming out of those metal forming process. So here our discussion will be mainly related to introduction to principle of metal forming and bulk deformation process, and also introduction to sheet deformation, that is sheet metal deformation, which are very important for those extensive manufacturing process of different utilities. So what is metal forming? Metal forming includes a large group of process, very extensively large, and which is plastic deformation, which is used to change the shape of the metal workpieces permanently. That is why it is plastic deformation process. Plastic means it is deformed under stress but permanently. Elastic means it will go back to its original dimension. That is the difference between elastic and plastic, and we are very much interested about the plastic deformation process, and that has to be done before the fracture. If the metal workpiece undergoes fracture, the purpose will be defeated. So we have to judiciously select the zone in which the plastic deformation will take place. And the difference between elastic and plastic is the yield point. Beyond the yield point, it will be plastic deformation. Under the yield point, it will be elastic deformation. As we want to give shape permanently, so it will be a plastic deformation process. This deformation results from the use of a tool. It is not just done automatically. We have to use some tool, usually called a die, in metal forming process, and which applies stresses and that exceed the yield strength of those metal. So those stresses will go for production of strain permanently. What is strain? Dimensional changes. And plastic strain means the dimensional change permanently beyond the yield strength of those metal. So we have to know what is the yield strength of the metal, and on the basis of that we have to find it out that how those metal can be permanently deformed in the plastic zone. And the metal therefore deforms to take a shape determined. How the shape will be determined? Determined by the tool. Tool will dictate what the geometry of the deformed shape, and it will be the conjugate profile of those tool. So tool, that is the die, will decide about giving the stress to bring permanent deformation into the workpiece of those metals. So we have to make the die, and the die has to be made, most of the cases, HSTR alloys. Which is HSTR alloy? That is high strength temperature resistant alloys, because if we want to do hot deformation process, the die has to withstand these kind of hot at elevated temperature so that it is not deformed. It has to deform, but it should not be deformed by that heat of those workpiece. So it has to be made by some kind of material which is resistant towards those heat and other things. So metal forming dominates the class of shape forming process, and shape formings are of different shapes. That is obviously done by that. And this is the classification. Classification, we have to know that what are the different kinds. There are two things, the main subdivision. One is bulk deformation and another one is sheet metal working. Bulk deformation means the volume to the surface to volume ratio should be small. Surface is less, volume is more, so that is bulky. And the next one is sheet metal, where surface is more, volume is less. That will be under the subdivision of sheet metal working. And this bulk deformation process mainly divided by the four very popular processes. The first one is rolling, where rolls are used in order to bring those permanent deformation, mainly reduction of those thicknesses. That is known as rolling. The second one is forging. With some die, all those things will be pressed together, and so that it is deformed permanently. Mostly it is hot forging, but there are some cases it will be also cold forging. Then the third one is extrusion. Again, some die those materials with a plunger. They will be just compressive force, and according to that it will come out of those die with some continuously it will come out as per the cross section. How the pipes and tubes and rods and other things can be manufactured. That is known as extrusion. So in extrusion, these compressive forces. And for the next one is wear and bar drawing. That means it is pulled. Again similarly, instead of giving compressive force, it will be just pull against a die, and through that die with that typical shapes it will have continuously. Mainly the wear and all those things are produced to that, and the operation is known as wear or bar drawing. If it is wear is produced, wear drawing. If bar is produced, bar drawing. And the other classifications of sheet metal workings are bending operation, deep or cup drawing operation, shearing operation, and miscellaneous other related processes. So bending operations, deep cup drawing, shearing, and all those things done on the sheet metal, because sheet metal operations and other things are also very much relevant to the many of the industries, very specifically for the automobile industries. So we have to go through those kind of operations, bend it, deep draw, and the shearing and other things, so that the different kind of products will be manufactured out of that. So introductory, that stresses applied to plastically deform the metal are usually compressive. Compression is the predominant force, but in some cases of the forming processes there are some bending and other kind of actions. So to be successfully formed, a metal must possess some properties. All metals cannot be deformed with ease equally. So there are some properties, and which properties will make the metal forming suitable, favorable. So desirable properties of metal forming include low yield strength and high ductility. Low yield strength means beyond that point it can be plastically deformed. So if the yield strength is less, so we need lesser force in order to permanently deform. If the yield strength is high, our machine has to be dinosaur, very big things, and rigidity and other kind of things will be in question. So those metals which are having low yield strength, easy to give shape, and high ductility. That means the flowability till fracture, that means endurance limit is high. In the plastic zone also, the problem is that if it is fractured very soon, that means it is less ductile. So it has to withstand those stresses, getting permanently deformed without having the fracture. This properties is known as ductility. And if a metal is ductile, that means it is easy to give shapes, another part of it, just like gold. We can give very, very complex shapes because of its ductility. So the ornaments and other things of aesthetic features, not maybe the functional one, because of the decorative features, can be easily imparted for a very highly ductile material like gold. So apart from its luster and inactivity towards oxide formation. Gold has a tremendous property of ductility, and that is why it is a very preferred metal for preparation of those ornaments. And these, importantly, these properties are affected by temperature. If the temperature is enhanced, the strength will be less and the ductility may be high. So temperature has a very big role to play in order to do that, and we will find it out where the yield strength is not that low. We have to increase the temperature to bring down the yield strength so that we can permanently deform the material with ease, with less amount of force. So temperature has a very, very important role to play, and that is why, because of the temperature has a role to play, we have two very important classifications. One is hot forging and the another one is cold forging. And recrystallization temperature differentiate those two processes from one to another. And then one can ask that why there are cold forging if the low strength is there, because cold forging or cold rolling or cold forming has certain advantages. So all processes are not hot forming. There are some processes of cold forming where it can be done, because cold forming has a lot of advantages. But where it is difficult, extremely difficult to go for cold forming, people go for hot forming, but hot forming has some disadvantages. So ductility is increased and yield strength is reduced when the work temperature is raised, and that is why in many of the cases, or maybe most of the cases, hot forming is more popular. So the effect of temperature gives rise to distinction between whatever we have already told, that between cold working, warm working and hot working. Cold working is at room temperature, slightly elevated temperature, warm working, beyond the recrystallization temperature, hot working. And there is also another parameter which is very important, strain rate. Strain is dimensional changes. Strain rate is dimensional change in unit time. So time is also a parameter. So how long it will take, because of the flowability and other part of it, the time is also important, that how much time it will take to flow the material, and that will dictate by strain rate. In case of fluids, we are very much interested about strain rate. In case of fluid, the stress is proportional to strain rate, and the proportionality constant is viscosity. But here the metal is not fluid, but whenever it is plastically deformable, so fluid-like properties are there, and that is why the fluid-like parameters are also being into consideration. So strain rate and the friction. In case of rolling, another part of it, the friction between the rolls and the sheets are also important, because that will represent all those pulling action by the rolls. And that frictional coefficient is also has to be with some dimension, some values within some range, and that will be good for all those operations. So there are additional factors that affect the performance of metal forming. And the bulk deformation process are generally characterized by whatever we have already discussed, that significant deformation and massive shape changes. Massive shape changes will be done in one go, and where it is bulk, because surface area to volume of the work is relatively small, and that is why it is bulky, because surface area is less and volume is more, so it is bulky. And whenever these kind of things are deformed, it is a bulk deformation process. The term bulk describes the work parts that have this low area to volume ratio, and whenever high, it will go for the sheet and other kind of things. The initial working shapes for these processes include cylindrical billets and rectangular bars and blooms, and they have their standard dimensions. These are the inputs of blooms, billets and bars for those metal forming operation. And the first one is rolling. We have seen that rolling is already in the first one, where two rolls are there. In our title slide, we can find it out that what is rolling. one can find it out. This is rolling, the left top corner. So this is rolling. One can find it out. This is rolling. Why it is rolling? Because two rolls are there, and these rolls will be rotating in the opposite direction, and that is responsible for the forward movement of those things, and dimensional changes are there. So left top corner is known as rolling because two rolls are involved associated with that. And this is a compressive deformation process in which the thickness of a slab or a plate is reduced by two opposing cylindrical tools called rolls, and these rolls rotate as to draw the work into the gap between them and squeeze it. So one kind of rolling action at the time of preparation of roti by our mothers and sisters, but it is one roll, another one is the flat surface. But in case of all those metal forming, two rolls are used in order to give proper shape, because it is a metal, it is not easy to deform, so two rolls are required in order to do that. And one can see all those things. The first one, left corner, it is blooms. Blooms are having some specific dimension, and they are having rectangular or the square cross sections where good amount of substantial value, I will discuss about those values, will be associated with those bloom configuration. And from those blooms, the structural shapes like eye sections, rails and other things are done. And these are all huge amount of products can be manufactured from those blooms, and those blooms are the product from the continuous casting line or all those kind of things. The second one is slab, where the thickness is less than the bloom and the length is big. Thickness is small, and those slabs are squeezed to plates and sheets and coils. So this is slab, and the third part is the billets, where cross sections but all those dimensions are less in comparison to bloom. So this is called billets, and billets are deformed in order to generate all those products like bars and rods. So these are the things, and these are the products coming out of what kind of initial products coming from the continuous casting line. So bloom is rolled steel workpiece with a square cross section about 150 by 150 millimeter. So length and height is 150, and it has long length, and this depending on the cross section it is called bloom. In case of slab, it is 250, the length, rectangular one, the length is 250 and the height is 40. So this is called slab, which is used to produce all those coils and sheets. And the billets are 40 by 40. 40 by 40, 40 length and 40 height, that is the cross section of a billet, and these billets are used deformed in order to generate all those products like rods and bars. And this is mainly of the wire drawing and other kind of activity can be carried out with that. Next is a very good representative figures. The top left portion, one can see it is transverse rolling, and the different kind of shapes can be generated immediately with those transverse very specific rolling. The next one is thread rolling. One has to remember that 95 to 96 to 98 to 99% of the threads of the world are produced by thread rolling process. It's a very, very good productive process. High tensile nuts and bolts and their threads, external and internal threads, are mainly generated by thread rolling, where the threads are also there on the roll, and because of this rolling activity the threads are generated. Then the next one is ring rolling, with those kind of arrangement and configuration with the rotation, deformation takes place, and this is known as a ring. So the ring is produced, so it is known as ring rolling. And the bottom left part is known as tube piercing, so that it is rotated against some typical kind of rolls, and there are mandrel. Mandrel is there, this is the mandrel, and from this mandrel it is responsible for creating those hollow part, which is a feature of tube. So this is known as tube piercing. And the right one is skewed, so that the rolls and other things, their axis is little bit not aligned together, not in one plane. So, and they are responsible for generating some very typical pieces, whatever the green figures and other things are there. And this is skew. Why? Because their axis and other things are not in one coplanar. They are not coplanar, and that is why they are called skew rolling activities. Now, shape rolling, the different kind of shapes can be generated out of that. So the different shapes in the rolls, and with their configuration, those different kind of shapes, eye sections and other things can be produced with those blooms, and they are fed into those rolls and typical type of structures, and mostly in the hot elevated temperature and hot workpieces are there, and they are used of those rolls, and according to that all those things will be produced. So blooming rolls, edging rolls, and roughing and horizontal and all those things, this will come. And then intermediate some kind of activities, horizontal and vertical rolls, and lastly we can generate all those eye sections which are responsible from the different kind of constructions of bridges and girders and maybe rails and other part of it. So this is the shape rolling activities. So shape rolling steel is a process which requires a lot of heat and lot of force. So those machines and other things have to take care of all those rigidity issues related to those things. And reheating is carried out around 1200 degrees Celsius, that means above the recrystallization temperature, and then the metal is continuously fed through rollers to draw the desired dimension. And because of that friction, those rollers able to just pull those things, the billets from the shapes, and productivity is very, very high, very high. And the popular shapes have good applications in the construction business, like I section, H section, U-shaped beams, and all sorts of sections and girders and all those things used in the construction and other kind of industry. So a country, their infrastructural projects and other things require all those kind of shapes, beams and girders in order to build up their infrastructure. So these kind of products are produced out of those hot rolling activity. And this steel is a strong material that is highly resistant towards shaping at normal temperatures. That is the problem with the steel. So elevated temperature is done so that their yield point goes down, so that the machine and other things making the entire operation feasible. And for that reason, the billets, the blooms and the slabs from steel making process are shaped into basic products at carefully controlled elevated temperature. And sometimes even at elevated temperature, whenever they are coming out of it, they are continuously get feeding into those rolling mills and other part of it, so that immediately we can generate all those things in a highly extensive production operations and all those things. So method that is most commonly used for shaping is to heat the steel around 1200 degrees Celsius in a reheat furnace. Sometimes if the temperature goes down and it is a room temperature, then you have to put it into the reheat furnace so that those things are hot enough above recrystallization temperature and easy for squeezing and giving shape. Rolls are arranged in pairs, housed in a strand and other part of it, and on the basis of those stands they are implemented those kind of rolling activities. And to change the shape of the material as strong as steel, it must exert huge amount of forces, thousands of tons, so that it will be a very big structure, it will be a dinosaur in order to implement those kind of things, because the rigidity of those structures are absolutely important, so that it can give certain kind of forces without getting buckled associated with that. So two main classes of products are produced: the flat products sheets or strips of uniform thickness, and long products like lengths of a particular cross section ranging from rectangular bars to double flange and all sorts of construction materials and other part of it, and that is depending on the size and the shape of the rolls. And for flat products, two horizontal rolls are set on above the other in an open housing configuration. So for long products, a series of specially shaped and angled rolls referred to as stands are used to transform. And this transformation strategy, depending on the shape, and those figures already I have shown where the different kind of sections can be done associated with those activities, and the British, European, and international standards define different dimensions for a wide variety of open sections, shapes, all those things. And in case of India, in Bureau of Indian Standards, they provide some guidelines associated with the production, their shapes and dimensions and sizes, which are available as a very, very popular construction material associated with that. So forging, the next class is forging. In a forging, a workpiece is compressed between two, whatever we have seen already in the title slide, compressed to opposite dies so that the die shapes are imparted into the workpiece. So it is open die forging, closed die forging, all those things. The female cavities are there, and where the workpiece material and pressed together so that it is deformed permanently in one go. Forging is traditionally a hot working process, mostly because it will be of lower yield strength at elevated temperature, but there are cases of cold forging also. The third one is that we have already told about introductory part, that extrusion. This is a compression process in which the work material is forced against those die, and it will flow through a die opening by taking the shape of the opening as its own cross section. One can come out of the tube, one can come out of the solid rod, bar, and all sorts of things. Like say toothpaste is coming out of a tube, it is an extrusion process. But here that is of a viscoelastic material, so that is not relevant here, but we have to produce this extrusion for those metals, and we can generate all those products like pipes, hollow pipes, tubes, solid rods, and other part of it in the form of extrusion, but mainly plunger pushes against the die. And there are two classes, one is direct extrusion and another one is indirect extrusion. So I am not going to discuss about here, because these are all sub varieties and there are different products which are associated with those processes. The next one is drawing, where another part of it, the difference between extrusion and drawing, the pulling will be there against the die, so that the rods and wear and other things can be coming out of the different bars and wear of thicknesses. But drawing is an iterative process. In one go we can reduce huge amount of diameter from big to very small. So it has to be done stepwise, and that is known as wear drawing. Now the next part is the sheet metal working, where the sheet metals and other things are processed and forming and cutting, and operations performed on metal sheets, strips and coils, and they are responsible for producing the different kind of container shapes and other part of it, which is useful for the automobile and other related industries. And whatever we have already told, that the surface area to volume ratio for those sheet metal is high. For bulk metal it is low, it is high for sheet metal. The ratio is useful means of distinguish between very easily distinguishable because of this ratio. So therefore bulk deformation process, this ratio is small, and for sheet metal the ratio is high. And one can see these kind of whatever we have discussed in the conventional process, and then we can see this is the process associated with sheet metal forming. The first one is bending. Because of some kind of arrangement, it is bent against the force and the velocity, and immediately it is bent in one go. The next one, B, is deep drawing operation. So the cup and other kind of formation will be done deep. As the depth is high, so it is known as deep drawing operation. The punch is associated with that, so that the deformations and other things in the appropriate shape with the forces. And the third one is the punch and shearing activity, so that one can cut across, and there are two things are there. One is blanking and another one is punching. Punching, where the things which are come out of it is waste, and which remains there, it's the product. The blanking, the reverse, whatever remains there, it is a waste, and whatever comes out to be there with those things die, it is known as blank. So blanking is also a product. An Indian company, Indian Fine Blanks, very much specialized in fine blanking activity and other things. They are having offices at Taratala. If one visits their office, they will find it out. All those sorts of blanking products and other things are available in their display. So if it is the blanking product possible for blanking, then tremendous productivity can be achieved. But the limitation is that very thick material and other part of it, metal, cannot be produced by blanking process. So these are all our discussions. Let us recapitulate all those discussions. We have started with the initial metal forming process, what is metal forming and what is the elastic and plastic zone, and we are interested in plastic zone. Then we have discussed about the bulk metal deformation process, which is rolling, forging, extruding and drawing. And then we have discussed about all those processes related to those sheet metal, which is bending, shearing, punching, blanking, maybe hemming, edge preparations and all those part of it associated with those things, and they have their extensive industrial application. Thank you very much for your patient hearing for those things of the introductory part of metal forming procedure.